everyone, welcome back to my YouTube channel Executephysics. Today we are going to discuss questions from 2023 question paper on the topic waves. First question, a transverse wave moves along a rope. The diagram shows the position of the rope at one particular time. So which two label points are one wavelength? There are four label points, W, X, Y and Z. So which is one wavelength? So the one wavelength would be from point X to point Z. This would be considered as one wavelength. So none of the others are correct. Y to X, no, it's not one wavelength. W to X, no. W to Z, it's more than a wavelength. W to this point would be one wavelength, but there is no point marked over here, so that is not the answer. Then X to Z, yes, that is the correct answer. And Y to Z is not one wavelength, so the correct answer is option C. Next question. Light in transparent plastic meets a boundary with air. Light is transmitted into the air only if the angle theta in the diagram is greater than 36. So what is the refractive index of the plastic? So here a light ray is incident from a plastic to air. Okay, and that transition from light would pass through plastic to air only if the angle in which the light is incident in comparison with the boundary is greater than 36. Okay, so what is the refractive index? To find out the refractive index, we know that refractive index is the inverse of sine of the critical angle. So first step would be to find out the critical angle. So critical angle is the angle formed between the normal and the angle of incident ray. Am I right? So is this the critical angle theta? No, this is not the critical angle because this is the angle formed between the boundary and the incident ray. We need to draw a normal over here to find out what is the critical angle. Okay, so it is the angle of incident. So we have a normal and the critical angle would be theta is 36, which we already know. So 90 minus 36 will give you the critical angle, which is 54 degree. Now refractive index is 1 over sine theta c, which is upon evaluation you'll find out to be 1.23. So the correct answer is option C, 1.2. Next question, you have a thin converging length with a focal length f. An object O is placed to the left of the lens. As you can see, where is the image formed and how does its size compare to that of the object? So you have an lens and an object O which is placed in between the principal focus. This is your principal focus. How do you understand that? That this point is a principal focus because the focal length is given to you. Principal focus, the object is placed between the principal focus and the optic center. So where would the image be formed? For this, let me explain this question to you with the help of a small simulation. So this is the simulation here. This is the principal focus. So the focal length over here is 4. Okay. So if an object is placed over here, where is the image formed? In between the optic center and the principal focus. This is the dotted lines shows the image form. So it is formed on the same side as that of the object and it's a virtual image and it is larger in size. So coming back to our question. So the correct answer is option C, because it is on this particular option says it is on the same side as that of the object and it is larger than the object. Correct. So this is the correct answer, option C. Next question, which diagram shows what happens when a ray of white light passes through a prism? So when a ray of white light passes through a prism, it undergoes dispersion because the difference in the refractive index between the prism and the air. So which is the correct answer? It is option D. Why? Because if we draw a normal over here from a rarer to a denser medium, it bends towards a normal. Am I right? And there is difference in colors. And if you draw a normal over here, it is from the denser to rarer medium. Am I right? So it bends away from the normal. None of those options is meeting this rule of refraction. So the correct answer is option D. Next question. A television TV transmits a signal to a television receiving dish. So this is the receiving dish and this is the TV station. From this a signal is being transmitted. A television has an on-off indicator. This is the on-off indicator light. The television is switched on by a remote control. This is the remote control which changes the indicator from red to green. Which electromagnetic wave used in these actions have the longest wavelength? So electromagnetic waves with longest wavelength is being used for long distance transmission of data. So out of these options A, B, C and D, which is having the longest data, longest travel, which is having long distance, it would be option A. So the correct answer is the electromagnetic wave with the longest wavelength is option A. Next question. A student makes a list of some applications of waves: medical scanning of soft tissue, sterilizing water, using sonar to calculate ocean. Which application uses ultrasound waves? So ultrasound waves is used for medical scanning, yes, to find out the growth of the unborn fetus. Medical scanning, ultrasound is done, yes. Then sterilizing water, no. Then using sonar to calculate ocean depth, yes, it's correct. So the correct answer is 1 and 3, so which is option C. Next question. A student investigates a magnification produced by a converging lens. He is using the apparatus shown in figure. Here you have an illuminated triangle. Here is the source of light. U represents the object distance. The object distance is the distance between the illuminated light and the triangle over here, as you can see, and the lens. Okay. So the illuminated object consists of a triangle shaped hole in the piece of a card. The figure shows full size the illuminated object. Measure and record h0 of the triangle shaped hole. So you just have to use your ruler to find out the length. So if it was something which shouldn't be scaled, then they would have clearly mentioned not to scale. Okay, since they have not mentioned that, we can simply use our ruler to find out the length of h0. Okay, so that would be around 1.4 centimeter. Next part of this paper 6 question. The distance between the illuminated object and the center of the lens is set to u, and it is 20 centimeters. Okay. Now the screen is moved until the focused image of the illuminated object is seen as shown in figure. Okay. So an enlarged image, which is represented by hi, has to be seen. So the screen is moved till this kind of an image is formed, an inverted image. If you look into the image, it's an inverted image which with a greater height. So the student repeats the procedure for u is equal to 30, u is equal to 40, 50 and 60. His results are shown on table 3.1. Measure and record in the first row of the table the height hi of the image. So you just have to measure it and you will get a value of around 4.5. Just do the measurement using a ruler. Since they have not mentioned not to scale, you're free to use your ruler. Okay, so the hi is 4.5 centimeter. Using your results from A and the equation h0 by hi, calculate the magnification value m. M represents the magnification. Magnification and record his value. So magnification m is the height of the original original object, and the hi is the height of the image. Okay. So in different situations, you just have to take the ratio of this to find out the magnification. So in the first step, the answer would be 0.31. How? What is the initial height of the object? It's around 1.4 and hi is 4.5. So 1.4 divided by 4.5 will give you 0.31. So the remaining they have already done. So it was a 2-mark question, 1 mark for this hi, height of the image, and second one for calculating the magnification. Next question. Plot a graph u on the y-axis and magnification m on the x-axis. You do not have to start your axis at the origin 0, 0. Okay, so let's take the reference of the table now. So you have to plot between u on the y-axis. So u is the object distance. The representation followed by its unit has to be clearly mentioned, and on the x-axis it's a magnification represented by m and it doesn't have any unit. Okay, so this carries 1 mark. Now let's do the scaling. X and y axis. X-axis 1 unit is 0.1 unit is 0.5 magnification. So magnification is maximum till 2.8. So it's 0. I have roughly taken it as 0.5 for 1 unit, and on the y-axis 20 centimeters because it is u. Okay, so 20 to 60 are the ratio, are the different values. So 20, 40, 60, and on the x-axis 1.0, 1.5 with a difference of 0.5. Okay, so u for when it was 20 centimeters, what was the magnification? 0.31. So 20 centimeters, 0.31 falls over here. So before plotting the points, it is important for you to analyze how much is each small division. How will you analyze that? So if it is 10 divisions, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, it's 10 divisions. So 0.5 divided by 10, 0.05. So each division would be 0.05. And at the same time here 20 divided by 10. So that would be 2. Each would be 2 units. So for 20 centimeter, with a division of 0.05 per division, you will get 0.1, 0.2, 0.3. 0.31 would somewhere be over here. So the first point is over here. Second point, for 30, 0.93. 30 is somewhere over here. 30 is 0.93. It falls somewhere over here. That would be the second point. Next one, 40, 1.6. 40 is over here, y-axis, and 1.6. 1.5, 1.6. Okay, falls somewhere over here. Next is 50 and 2.3. 50 would be somewhere over here, and 50, 2.3 would be this point. And 60, 2.8, it would be over here. So let's draw the line of best fit. At least 3 points we have to join together. Okay, so yes, this is the line of best fit. Since I have already mentioned you do not have to start your axis at origin, then it's fine. Even if you, okay, so this is a 4-mark question. And how is a 4-mark distributed? By properly labeling the x and y axis and giving it proper divisions, giving the proper scaling, giving the points accurately as per the table, and drawing the line of best fit. This is how the 4 marks would be divided. Okay. Next question. Determine the gradient g of the graph. Show clearly on the graph how you obtain the necessary information. So this is the graph. So we know that gradient or the slope is by plotting a triangle across any 2 points you take and plot the triangle and get it across the x and y axis. So this is the triangle that I've taken. Any triangle on the I've taken any small triangle, and this is the shaded area, and I have to find out the slope now. It is change on the y-axis by the change on the x-axis. Okay, what is the change from this point to this point would be 50 to 20 on the y-axis, and on the x-axis what is the corresponding change? 2.5 to 0.3. So 0.36, it's more than 0.31. It's at this point, so let's take it as 0.36. So, and on the y-axis it was close to 52. So it is 52 minus 20 divided by 2.5 minus 0.36. So you'll get an answer of 15. So this gradient in the answer key, there would be a range of values. Your value should fall between that range. Okay, you can take any triangle. Okay, so practice this graph correctly to get full marks for the graph. Okay, so it is a 2-mark question. So on the graph you have to show this triangle, which 2 points you have taken to get the slope has to be clearly marked with the help of this triangle. Okay, next question. Describe one difficulty that might be experienced while measuring the height of the image. Suggest an improvement to the apparatus to reduce its difficulty. So the main difficulty would be in measuring the length of the image would be handling the ruler. So holding ruler in hand to take the reading of the image formed on the screen can lead to inaccuracy. That would be the difficulty. And improvement is that we can have an apparatus which is kept to keep the ruler properly. So that would be the improvement. So it's a 2-mark question. So 1 mark for the difficulty and improvement. Okay. So that's all. Hope you have understood the questions that we have discussed. I would be uploading one more video on this waves topic, because it is a very vast topic and we have a lot more questions to discuss. Okay, so hope you have understood. Practice these questions, especially the paper 6 ones. Okay, see you in the next video. Take care.